before we start formulating the proof obligation for refinements, which I'm pretty sure you're excited about, let's now do some necessary groundwork before we can do the formulation. But it's not going to be very long, brief. Right, so first of all, I would like to talk about the before-after predicates. We spoke about this concept already when we talk about the initial model, but there's one minor new detail which I think you should really know about as well. Right, so this is really the concrete version for the ML in and ML out. Just remember, we call these the concrete version because the same two events actually exist already in the initial model. Later in this lecture, we'll see two more events that are actually not part of the initial model. They are simply completely new events that we introduce. In the inheritance analogy, you can think about whenever you're adding a subclass in the inheritance hierarchy, you can either overwrite or redefine the existing methods you inherit from your parent class, or you can actually introduce new methods. It's really similar idea over here. But now let's talk about the events that actually exist in both contexts, in both states. Right, let's now talk about the before-after predicate. The only thing I want to mention is this. Right, we still got the idea about pre-state, post-state, and also state transition. Right, let me just remind you, just repeat if you don't mind, quickly one detail that's so important. Whenever you look at the action part, right? So this is really the actions for each individual events. And we talk about the left-hand side of the colon over here. So this is the left-hand side. And this part over here is the right-hand side, right? And then we also got this part over here is the colon equal, right? The way to think about it, the best way, I would suggest not to really think about it is like a programming assignment. Maybe not. You want to think about it more like a specification. So this means becomes. But what becomes what? So this part over here, the C, is really the post-state value of the transition. Post-state value of the transition. Whereas this part over here is the pre-state evaluation, right? Or evaluation or expression, evaluation of the pre-state values. So if you combine all these together, something we spoke about before, but I want to emphasize, the post-state value for variable C becomes, after the transition, the pre-state value evaluation like this. So the pre-state value of C minus 1. Okay, and as I actually also hinted before, in this case, you might be wondering, we're only talking about C is actually becomes C minus 1. What about A and B? Because if you look at the state space for the concrete model, we actually got A, B, and C. But what about, we only talk about A. What about B and C? We didn't say that. You can think about anything, any variable that's not really mentioned, that means they remain unchanged. It will be as if the following. So over here, since we didn't mention the other two variables, it will be as if. We also got B becomes B. And also C becomes C. It will be as if. However, for our convenience, we may not actually want to write anything like this, right? To really say B is simply become its pre-state value, meaning that nothing has been changed. So the convention would be whenever you see the action part for any events, either in the abstract states or in the concrete state, if some variables are simply just missing, in that case, it simply means those variables stay unchanged between the transition, right? So that's why you will see that explicitly we actually got over here C becomes C minus 1. So that's why we actually got C prime is equal to C minus 1. Anything that's kind of implicit that we didn't really mention, it would be as if this. So that will correspond to the before-after predicate. However, even though in the action part we can simply omit all the variables whose values will stay unchanged. But when you talk about before-after predicate, it would be important to actually do A prime equals A and also B prime equals B. If you remember what we did before when we tried to derive the guards for ML out, we actually used this before-after predicate to say B prime equals B and C prime equals C. When we actually go from here into here by doing the substitution, if you remember, right? So that's why in the before after predicate level, even though the variables may stay their value unchanged, but you still need that part of the before after predicate to do the substitution when you do any reasoning, right? That's something I want to point out to you, right? And similar idea for MLL as well, right? You can see here we explicitly mention about A over here, so that's why you will see A prime is equal to A plus 1, and anything that's implicit will be B and C. In that case, we got B. We actually got B prime is equal to B, and also C prime is equal to C. I just noticed that I got some typo over here. Again, sorry about that. So here we explicitly mentioned about C. That means A and B should really remain unchanged, right? So what I really meant to do over here, let me do it again. I think I did a right highlight, but when I wrote it down, it was wrong. Let me fix that right away. It will be as if A prime is equal to A. It would be as if A becomes the pre-state value of A, and also B becomes the pre-state value of B, right? That's really what I meant to write over here, right? So you can see this one corresponds to this, right? That's about the before after predicate I would like to talk about. Mainly, any variable not mentioned, they should really stay their values unchanged. Okay? The final remark is actually very important. When we express the proof obligation, we have to use the before after predicate. So even for those variables who stay their values unchanged, we still need to consider them to do the substitution. Right, the next one I would like to talk about is to really clarify about abstract versus concrete. So there are three things that we can talk about in the case of the refinement model versus the abstract model. We can talk about states, we can talk about invariants, we can talk about the events. So let's now just clarify them very quickly. Okay. So what I want to do is, you can definitely look at the slides, but I would like to just switch to the page right away, just to do some annotation, and then we are done with this mention about the abstract versus concrete. Right, so there are three contexts we want to talk about, right? So one is about the variables. We got abstract variables versus concrete variables. So you should really know these terms very well. Okay, so in the abstract context over here, we actually got abstract variables. So this part over here, so this is the abstract variables. Abstract variables. Or sometimes we simply call abstract states. Well, of course, you can think about the abstract states consist of abstract variables. That's another way to think of it. And similarly, for variables that exist in a concrete model, so what we have is the concrete variables, which constitute the concrete states. Right, so that's about the variables and states. What about invariants? Well, in the initial model or in the abstract model, they only involve the abstract variable or abstract states. You can see they only get involved in the n over here and the n over here, right? So these are just the abstract variables. So these are called abstract invariants. So these are called abstract invariants. Okay. So abstract invariants involving abstract states only. They cannot involve the concrete states, which makes sense. When you are constructing the abstract model, you wouldn't really know exactly how later you might refine the abstract model into the concrete model. However, the opposite is not true. When I am trying to construct the concrete model N1, I definitely should have the abstract model that was constructed earlier in my mind, right? That's the difference. So that's why when you try to define the invariance for the abstract model, it's really simple. It's really straightforward. You only have to involve the variables in the abstract state space. In the case of the concrete invariance, you have to think about some invariants which will involve both the abstract states and also concrete state. That's also something very important to note. Right? So here, very similarly, you can see these invariants will involve at least the concrete states. Right? So here, let me put it down here. So these are called the concrete invariants. Concrete invariants, and involving at least at least. I'll explain what at least really means. You will see the at least term also in the slides. At least concrete variables. Right? You can see, for example, the concrete variables would be, let me try to highlight them. You can see A, B, and C, and also A, B, and C, and also A and C, right? So these are all the concrete variables. So if the invariant itself involves the concrete variable, which it should be because we are talking about the invariance for the concrete model. However, there would be a kind of a concrete invariance which also involve the abstract variables, in which case, of course, it will still be considered as the concrete invariance. But this kind of invariant would be very important for us to really argue that the concrete states is consistent with the abstract states, as we did before, right? When I try to illustrate the concrete states is simulated by the abstract states, we have to use the invariants that actually involve both the concrete states and also the abstract state, right? That's really important. Let me also write it down over here. Yeah, I know sometimes I need to repeat, but hopefully that also help you just to recall your knowledge, right? Just try to do repetition whenever necessary. Okay, so these are the special kind of concrete invariants involving both state spaces, namely the abstract state space and also the concrete state space. Right, so that's about the difference between abstract invariants versus concrete invariants and the special kind of concrete invariants. Finally, let me try to clarify about abstract events versus concrete event. This one should be rather easy. So you can see here, the reason that we got abstract event versus the concrete event, that means the event itself exists both in the abstract model and also in the concrete model. I should have swapped the order of these two anyway. So you can see ML out has the abstract version and also concrete version over here. And also MLN has the abstract version over here and a concrete version over here, right? Let me just use one of them for example. So you can see over here, this is the abstract version of the events. So this is the abstract version of MLN, ML out, sorry. And this is also the abstract version for ML out. Concrete version, I beg your pardon. Okay, so this part over here, so you might hear me sometimes actually say maybe abstract when I really meant concrete or vice versa. In that case, just notice what I wrote on the notes. So I'll try to avoid saying things inconsistently, but I really meant sometimes not exactly what I said, right? I'll try to minimize that. So this will be the concrete version of the same events. Right? Of course, sometimes we also say this is so-called abstract version. Either we can say that's the abstract version of ML out, and we can say that this event is also an abstract event. And this, similarly, it is called also the concrete events. And one more thing to say, you can see in the case of the abstract events for both the guards and also the action, right? Both the guard and the action, they can only involve the abstract states. Involving, okay, let me just, I think I can just say abstract states. Right, of course, over here, we cannot refer to A, B, or C. We cannot, right? Because at the point of constructing the initial model, we don't necessarily know the existence of the concrete model. On the other hand, if you look at the concrete version of the ML out, in that case, you can look at the guard over here, and also you can look at the action over here. So what variables are involved really over here? You can see here we got the A, B, and C, and also A, right? We only involve the concrete variables. Actually, let me make it clear. In the case of the abstract events, you should only involve the abstract states. In the case of the concrete events, you should only involve the concrete states, right? In the concrete event, you should not also involve the abstract state. However, in the case of the invariance, so this is where we try to specify the consistency constraint before the abstract state and the concrete states. So that's why you may also have some invariant conditions involving both the abstract and also the concrete, right? Right, but for the events, they only can involve the concrete states. Concrete states. Alrighty. So that's about the distinction I would like to draw to you, right? So anytime when I say concrete events versus abstract events, when I say concrete invariants versus abstract invariants, when I say concrete state versus abstract state, you should know which one I'm talking about. Because especially when later on we actually got different refinement model, so each time you should really think about what's really the context we are considering. Let's go back, and everything has been said in this slide over here about abstract versus concrete states and invariants, and also over here the abstract versus concrete events, right? You can definitely study the slide as well. And let me just say one more point over here. A new events may only exist in M1, the concrete model. It's pretty much like introducing a new methods in the subclass or the child class. And we'll deal with this kind of events separately later. But for now, we only consider the redefined or overridden events. That's what we're doing here, at least for this week. I think that we'll definitely start talking about the new events. If not this week, then definitely next week. The final part I would like to talk about in the current video, I would like to just mention about the formal components you will need in order to formulate the proof obligation. And we have seen many of them already earlier, so I'm just going to point them out so you can see the correspondence, right? Because now when we talk about refinements, we need to consider both the abstract states and also the concrete states. So anything that you learned earlier for the initial model formal components, you have the concrete counterparts as well. Let's see. So this is our concrete model, and let's see what formal components we have to introduce as the counterparts for the abstract formal components. And we still got a list of contents and also axioms. In our case, for the first refinement and the abstract model, they just happen to have the same constant. Or you can think about they share the same constants. In theory, you can also introduce new constants in the refinements model. Pretty much like in a subclass, you can definitely introduce new attributes. Similar idea, like a new constant. Right, so we got abstract variables in the pre and post states, v and v prime, and we also got concrete variable as well. We explained already about abstract versus concrete, so for that one I'm not going to repeat. And for convention, we're going to use w and also w prime, right? So v and w. You can think about w follows v alphabetically, right? And don't forget the formal components actually got a list. So we got a list of a, b, and c, and this is a singleton list as we learned before, right? And also a prime, b prime, c prime. And also we got the notion about abstract invariants versus concrete invariants. So now this is something I want to point out to you formally. You can see for the invariants over here, you only involved the abstract states. Let me show to you. Okay. So here we are talking about the abstract invariants. In that case, it would be this part over here in the abstract model. So we got involved abstract variables over here, right? So you can think about the variables over here is formulated just as v. And invariants over here. So these are the v that we talk about. On the other hand, we got the concrete invariants which exist in the concrete model over here, right? So a, b, c, and also a, and also c, right? So all these are the concrete variables. Concrete variables, we use w to denote the list over here. So that's why in the case of the abstract invariants, we only got the constants and also the abstract variables. And in the case of the concrete invariants, we definitely should actually get the concrete variables for sure. Right? Let me just use the right color over here. We definitely should involve the concrete variables at least. But for some special kind of concrete invariants, we may also involve the abstract variable as well. Right? That's something you want to also pay attention to the details. So these are the abstract variables. And in the case of concrete invariants, you should at least involve the concrete variables. Okay, let's now move back. That's about the first group of formal components. You can see we got variables, we got abstract versus concrete, and also for the invariants, we also got abstract versus concrete. Let's now move on to the second group. And we got the guards. remember we got the notion between abstract versus concrete events. So that's why the guards will be called the abstract guards and also concrete guards. Let me show to you very quickly. You can definitely read the slides, but let me show to you, right? Just take one example. You can see the ML out over here. So this guard over here is a abstract guard for the abstract event ML out. And this part over here is the guard for the concrete events for ML out, which is for ML out. Yes, over here, right? So this part over here is the abstract guard for the abstract events. So abstract guards. On the other hand, this part over here is a concrete guards. And when we formulate the refinement proof obligation, we need to distinguish between the abstract guard versus the concrete guard. So that's why I need to write this down explicitly for you, right? So it's also the concrete guard, right? Let's now move on. Okay. And the final formal components will be, remember we talk about the E. So the E here is the effects of some events when we talk about the initial model. And in that case, it will only involve the abstract variable. So now we need to introduce another counterpart for the concrete state space. So that will be, you can see the W over here. So we call F. So F follows E alphabetically. So I think that's why we are using this F, capital F over here. So that'll be the effects for the concrete events action. So that's mainly about, so here, let me show to you very quickly. Right, so here you can see we got the abstract events effects. So that'll be E over here. And also we got F. That's the effect for the concrete events. Right, you can see in this case, unlike the invariants, for the concrete invariants, which we might where we might involve both the abstract and concrete variables, but for the concrete events effects, we can only involve the concrete variables. Right, that's also something I mentioned before. Right, and what about the effects? Let's just say for one example. Right, I'll just put it down. So we can say the E, right, the constant, also the abstract variables of. Let's talk about ML out. Right, for ML out, what will be the effects for the variables, right? So if you look at ML out, it will be just n plus 1, because we only got one abstract variables over there, so it will be n plus 1, right? Just n plus 1 over here. And what about in a concrete counterpart? So that'll be F. That'll be the effects for on the concrete variables W of ML out. In this case, the concrete state space actually got a list of 3 variables. So that's why the effects is going to be a list over here, right? And if you look at the concrete version over here, A will become A plus 1. So that's why you're going to have A plus 1 over here for the first variable. And for the other two unmentioned variables, B and C, they remain the same, right? So it's simply just going to be B and also C. They remain their pre-state value, right? It's something also very important to notice, because when we actually formulate the proof obligation, you should really know what each formal component really means. Right, so you can see here, so here I'm only talking about A plus 1 for, I should really edit this, okay? So I think if we download the slide, this would have been modified to A plus 1 and then B and C. So this one over here should be A, B, and C minus 1. That's what you will see on the slides. Right, so now we are done with all the groundwork for the formulating the proof obligations for refinements. Let's now do it.